We have finally reached the end of chapter 7. So, the last thing that we're going to do in chapter 7 is solve with trigonometric identities and with factoring and just plain solving. And again, when you're doing your questions in your textbook, only solve from 0 to 2 pi. Keep things simple. So these are called solving with trigonometric identities because what's going to happen is you're going to look at a question and there's going to be way too many things. Like there's a tan squared and there's a secant squared and there's a tan x, which makes me start thinking about trinomials, right? When you go squared, not squared, and then a constant. But this weird secant squared x messes everything up. So we are going to use our trigonometric identities to make these simpler for ourselves. So I'm going to bring up my formula sheet, wherever that went. There we go. And we're going to look to see which of these we are going to use. Now, I have a tan squared and I have a tan. My outlier is this secant squared x. I think about Pythagorean identities because I can look at here and say, oh, look, secant squared x I could write in terms of tan, and I could make this 1 plus tan squared x. I have also seen people change everything into sines and cosines, and then this becomes a rational equation that then you have to like multiply the lowest common denominator. Feel free to do that if you want, but I will say in these questions, there'll be only one thing that doesn't belong, and you're just going to replace it with something. So we've got tan squared x plus 4 equals 2, and then we're going to replace that. Let's just double check I don't mess up that identity, right, with 1 plus tan squared x, and then plus tan x. And then we're going to simplify. So I'm going to distribute my 2. So I've got tan squared x plus 4 equals 2 plus 2 tan squared x plus tan x. Then I know I'm going to be solving this one by factoring because of having these two tan squareds and a tan. And so I'm going to move everything to one side. So anytime you're going to solve by factoring, anytime it's quadratic, right, you're going to make it equal to 0 and solve. So I'm going to get rid of the tan squared x. I'm going to move everything to the right because then I can have a positive tan squared x. You never want a negative tan squared x if you can help it. And then I've got a minus 4. So I've got 0 equals, and I'm going to write these in descending order. So I'm going to put tan squared x plus tan x minus 2. Then I'm going to solve this one by factoring. Now, because the a value is a 1, I'm looking for two numbers that multiply to give me negative 2 and add to give me positive 1, which are positive 2 and negative 1. And again, if that's a struggle for you, feel free to use the quadratic formula. Now I don't have to do the whole thing because I know that to multiply to get tan x in front, I can simply put a tan x and a tan x, and then I can put a plus 2 in one of the brackets and a minus 1 in the other bracket. Now I am going to solve. For this one, I get tan x plus 2 equals 0, and for this one, I get tan x minus 1 is equal to 0. Now let's keep going. So for this one, I would get tan x is equal to negative 2. Now, this is in my restricted range because my range is from negative infinity to infinity. If this had been a cos or a sine, I would have said, nope, I'm done. But is this a special triangle? Like if you think of this one, right, C-A-S-T, so let's just think of tan as being negative here, okay? If my opposite is negative 2 and my adjacent is 1, we don't have any special triangle that does 1 with a 2 as the opposite. So this is one of those ones we're going to touch a calculator. So for these ones, I'm going to say that I'm going to find my reference angle. I always do it of the positive, so I'm going to do the inverse tan of 2, right? So I'm going to say that I'm finding my reference angle here. So if I type into my calculator the inverse tan, I'm in radians, second function tan, of 2, I get to 4 decimal places 1.1071. And then which quadrants am I in? Well, tan is negative in quadrant 1 or 2 and 4. So in quadrant 2, I'm going to do pi minus 1.1071. I'm going to store that. Okay, pi minus that gives me 2.0344. And then in quadrant 4, you do 2 pi minus that. Oof, I just wrote something really bizarre. 1.1071. Transcription errors are so rampant. Store and recall in your calculator if you know how to do that. And if you don't, come and see me. So 2 pi minus gives me 5.1760. Awesome. And then we'll solve this one. What's going to make tan x equal to 1? Well, that is a special triangle. So again, CAST. Tan is positive in quadrant 2 and quadrant 3. It's my 1, 1 root triangle. Sorry, 1, 1 root 2 triangle, which makes my reference angle pi by 4, which makes my answers pi by 4. And then if this is 4 pi by 4, it makes my answer 5 pi by 4. So I get 4 answers. 2 of them are awful, right, and approximate, and 2 of them are exact. So you give exact solutions where possible, and where you can't, you give decimal answers. All right, one last question, and maybe I'll put this on another page so we get more room. But I've got a double angle identity and another double angle identity. Oh, it's a cos 2x1, right? We're all groaning. So let's look at what happens. Let's start with the easy one first. So we're going to change sine 2x into 2 sine x cos x. And that's multiplying by a sine x. Then I'm going to have this weird cos 2x that I have to replace it with something, but I'm not going to decide on what that is yet. I'm going to put the cos x out for here, and I'm going to put equals negative cos x. Now, I'm going to try to decide what to put in here. I might even want to go another step further to say that this is going to become 2 sine squared x cos x minus something equals negative cos x. So if I've got a 2 sine squared and a cos, this already has a cos. I could make it have a sine squared, right? In fact, I can make it have a 2 sine squared. So let's go to our formula sheet. Okay, we're looking at our cos double angle identities. We can choose from cos squared x minus sine squared x, 1 minus 2 sine squared x, and 2 cos squared x minus 1. So I'm going to choose the 1 minus 2 sine squared x. So we're going to put 1 minus 2 sine squared x, and let's just see what happens. So if I multiply that through, I get 2 sine squared x cos x. I'm distributing the minus 1, so I've got minus 1 plus 2. Oh, right. Well, yeah. I mean, whatever, we'll just carry through with this. So I should have multiplied negative cos x through. I didn't see this cos x. So we'll just put plus 2 sine squared x. And then this is a bit tricky because we still need to multiply this by cos x. Okay, now let's multiply the cos x through. So I've got 2 sine squared x cos x minus 1 cos x plus 2 sine squared x cos x. Man, I feel like I made that really complicated. Sorry about that. Right? Like this is the way that it was written, but really you have like a minus 1 out front here. And so you can do minus 1 times cos x and then multiply that through. It would have made it a 1 step instead of a 2. But anyway, we're going to keep going. So when I look at this, I'm thinking solve by factoring. So I'm going to make it equal to 0. So I'm going to add cos x. I'm going to add cos x. And that's going to make the cos x go away. And then I'm left with 2 sine squared x cos x plus 2 sine squared x cos x, which gives me 4 sine squared x cos x's equals 0. And this question that looked impossible to start, I actually only have to find where does sine x equal to 0 and where does cos x equal to 0. So sine follows y. 1, 0, negative 1, 0. Or think of your graph, right? 0 and pi. Okay, so for this one, x equals 0 and pi. For the cos x equals 0, cos follows x, so we'll have 0, 1, as well as 0, negative 1. So x would equal pi by 2 and 3 pi by 2, which means that my overall answers in numerical order, because when you check your answers in the back of the book, that's how they'll be written, is 0, pi by 2, pi, and 3 pi by 2. Congratulations. Chapter 7 is a bit of a beast. I did change it, so I'm hoping that it's feeling a little bit better. I separated it into two parts. The first half is all about simplifying expressions with trig. The second half is all about evaluating and solving with trig. Hopefully you love it.